Stat Scholars. In this video, we're going to start calculating probabilities for normally distributed variables. And we're going to start with the old school method, which is how do we do it without a calculator? And the answer is we're going to use a probability table. In order to use the probability table for the normal curve, the first thing we have to do is convert any of the given data values to z-scores. And the reason we're doing this is we know that the table is based on the standard normal curve and not some random general normal curve. Next, we need to draw a labeled standard normal curve. And we need to mark the area of interest. And remember, when we say labeled, we've labeled the axis as z, we've marked the mean in the middle, we've marked 3 standard deviations out in each direction, and we've labeled them with appropriate numbers, which for standard normal, which would be 0 in the middle, and then 1, 2, 3 out in each direction. Once we've marked the z-score or z-stars that we're given and the area that we're interested in finding, we're going to use the table to find the area to the left of our given z-scores. And the reason I'm saying area to the left is your probability table only does areas to the left. It only does less than problems. We won't always be looking at less than problems, so we're going to have to work backwards in step 4. In step 4, we're going to use the picture to determine the probability of interest using those left values from step 3. We're going to do some together, both so you can see what the table looks like and get some practice with finding areas to the left versus finding the area of interest. So for our example, we're looking at the weight of cogs for Mr. Cogsworth factory, and they are approximately normally distributed, have a mean weight of 0.75 pounds, and a standard deviation of 0.05 pounds. So I know that X follows a normal distribution with a mean of 0.75 and a standard deviation of 0.05. It says, what is the probability that a randomly selected cog will have a weight less than 0.67 pounds? And I know I don't want X, I want Z, because Z follows a normal with a mean of 0, standard deviation of 1. I know how to deal with that. So I want the probability that a cog will have a weight less than 0.67. I'm going to convert that to Z is less than, and I need to figure out what that Z is. So over here on the right, I know I take my X value, 0.67, I subtract the mean, 0.75, I divide by the standard deviation, 0.05. And let's see what that gives us. I get negative 1.6. I'm going to go to my normal distribution, which I've pre-drawn here. I'm going to label it as if it were Z, because I'm working with z-scores. I know mean of 0, standard deviation of 1. And then I'm going to mark in a different color that z-score. Negative 1.6 is here between negative 1 and negative 2, and I want less than, which is to the left. That area is going to be my answer here. To find that, I need to look up this value, in the standard deviation, or not standard deviation, standard normal data table, sorry. So we're going to scroll down and do that. Keep in mind our z-score is negative 1.6. So here is the table of standard normal distribution values. This is the same one I've posted in Canvas. And you'll notice it says Z, and you'll see numbers along the first column and numbers along that top row. And what it's doing is it's labeling your z-score out to 2 decimal places. So this is the first decimal place, this is the second decimal place. We know we had negative 1.6, which is negative 1.6, negative 1.60. So I need negative 1.6 here, and I need 0, 0 here. So I know I'm in this first row, or first column rather, and I'm going to scroll down until I see negative 1.6, and I see it right here. So that value that's in the negative 1.60 intersection is 0.0548. 0548. So back up to our picture. This area here is 0548. 0548. Come on, Mr. J. So the probability that a randomly selected cog weighs less than 0.67 pounds is 0.0548, or 5.48%. You'll notice the table gives values to 4 decimal places, which is why I tend to round probabilities to 4 decimal places. We're going to do 2 more really quick. We already know they're both standard normal, so I'm going to go through and label them as standard normal. I don't know about you, but if I know I'm going to be doing things on repeat, I like to do the rote labeling first. And same setup. So this one says, what is the probability randomly selected cog will weigh more than 0.9 pounds? So probability X is greater than 0.90. And I want to turn that into Z is greater than, and we need to convert 0.9 to a z-score. So 0.9 minus the mean of 0.75 divided by 0.05. I'm lazy. I'm going to pull my answer from the last problem and just change this to 0.90. And I get 3. So Z greater than 3. I'm going to come over to my picture. I'm going to mark that value. We're here. I want this probability here. I already know from the empirical rule that's going to be super, super tiny. But let's go ahead and find 3.00 in our table. So notice this first page is Z's are negative. I want a positive 3, which is all the way down here. So 3.0, and I know second O is this one. And it says 0.9987. 9987. 9987. And the reason it says 9987 is that 9987 is this area here. The question is, how do I get the red area? And the answer is, I know the whole curve is 1. So I go to my calculator and I subtract. And I get 0.0013. So if I want a greater than, and my table only gives me less than, I'm going to do 1 minus the less than answer. All right, last example says, what percentage of Cogsworth cogs weigh between 0.68 and 0.82 pounds? So probability that X is between, so 0.68 less than x less than 0.82. So anytime you're dealing with a between statement, we're always going to write it as lower number less than x less than bigger number. So this time I need to do two z-score calculations. So 0.68 and 0.82. And I'm going to do that on the calculator really quick. So 0.68 gives us negative 1.4. Less than z, less than, and then I need to do 0.82. And I get 1.4. So marking this here, I want negative 1.4 to positive 1.4, and I want this area here. I know my table is going to give me this area and this area. In order to get this area in between, I'm going to subtract the big area and small area. So we're going to have to do a subtraction problem for this. So first we're going to look up the big area, the one we're going to subtract from, and that's the positive 1.4. So we scroll back down, positive 1.40 would be right here, and I get 0.9192. And then I'm going to do the same thing for negative 1.4. Ooh, too far. So negative 1.40 is right here, and that's 0808. And we get 0.8384. And for this one, we're going to ask ourselves, does it make sense? And the answer is definitely yes, because I know the empirical rule says 68% within 1, 95% within 2. I'm in between 1 and 2, so I should be between 68 and 95. And I am, which is perfect. All right, if you have any questions on how to read that table or draw these pictures, feel free to let me know. Otherwise, I will see you in our next video.